Hello and welcome back to Math 1500 Applied Business Mathematics, Connecticut State Community College. In this video, we're going to look at matrix addition and scalar multiplication. In previous videos, we've used matrices in order to solve systems of equations. In this video and the next couple of videos, we're going to get a little bit more in depth into operations with matrices, working with matrices in an algebraic type sense. As a reminder, matrix notation in m by n matrix is an array of numbers with m rows and n columns. So for example, if I have the matrix 1, 2, 4, 6, 8, -3, that's an array with 2 rows and 3 columns. We would call that a 2 by 3 matrix. Okay, so just some vocabulary here that you want to pick up as we go through the video. Not just this video, but over the next couple. A row matrix, we'll talk about that in a little bit. Column matrix, a square matrix, those will come up. I'm going to talk about the entries, the ith, jth entry. Okay, you'll notice that 2 is in the first row, second column. So that would be the 1, 2 entry, first row, second column. 4 would be the 1, 3, because that would be the element that's in the first row, third column. Where I had mentioned 2, 2, that would be the 8 because it's in the second row, second column. That's what we mean by the ijth entry. Okay? We'll talk about matrix equality, addition, subtraction, scalar multiplication, and then I'm mentioning matrix multiplication, but that's really what the next video, the next section will be about, is multiplication. So matrix, dimensions, entries, that sort of thing. This is going to repeat myself a little bit. An m by n matrix, it's a rectangular array of real numbers, m rows, n columns. We always refer to m and n as the dimensions. M is rows. Rows always comes first. So if you look at matrix A here, 2, 0, 1, 3, 5, -6, that matrix is a 2 by 3 matrix because it has 2 rows, 1, 2, 3 columns. Okay. B, notice that there are 1, 2, 3, 4 rows and there are 2 columns. We refer to that as a 4 by 2 matrix, again, because it has 4 rows and 2 columns. And like I mentioned before, 10 in matrix B, that would be the 2/1 position because it's the second row, first column. Okay? Matrix equality is very simple. In order for matrices to be equal, they must be identical. Okay? The only number equal to 2 is 2. The only matrix equal to matrix A would be 2, 0, 1, 3, 5, -6. If I want a matrix equal to that, it would have to be the same thing, 2, 0, 1, 3, 5, -6. In order for matrices to be equal, they must be identical. A row matrix, column matrix, square matrix. Again, some of this is fairly simple, I hope. Notice that matrix A in this example has 1 row and 3 columns. That's a 1 by 3 matrix. It's got 1 row, it's a row matrix. If you look at matrix B, it's a 3 by 1. There are 3 rows, there's 1 column. Because there's only 1 column, it's called a column matrix. A square matrix is where m and n are the same. So matrix C has 2 rows, 2 columns. That would be a square matrix. A 3 by 3 matrix, 4 by 4, 5 by 5, those would all be square matrices. Okay? If you look at my examples here, numbers 3 and 4, none of those matrices are square matrices. They're all 3 by 2s. Okay? So let's just talk matrix addition. To add the matrices, I'm simply going to add corresponding indices. So I've got a 2 by 3 plus a 2 by 3. My resultant matrix will be a 2 by 3 matrix. To find this element that's in the first row, first column, I'm going to take the 2 and the 1 and add those together. To find the element that's in the first row, second column, I take the elements in the first row, second column, the 4 and the 5, I add them together. To find the element, the entry, that's going to be in the second row, second column. Second row, first column. I take the -3 and the 2. Those are the two terms in the second row, first column. I add those together. Okay, over here I'm putting lines. They really don't need to be there. I'm just doing that to help us see what's up. Okay. 7 plus 6. Those are the two elements in the second row, second column. Second row, second column over here is the 7 plus 6. 5 and 4 are 9. Those are the elements in the third row, first column. They create the 9 in the third row, first column. And then finally, -6 and -2 is a -8. Okay, you'll notice in number 4 that I have the same two matrices, except that we are subtracting the matrices. Okay, 2 minus 1 is 1. 4 minus 5 is -1. -3 minus 2 is a -5. 7 minus 6 is 1. 5 minus 4 is 1. I got a lot of 1s here. And then -6 minus -2 is a -4. So to add the matrices, I simply add the corresponding elements. To subtract the matrices, I simply subtract the corresponding elements. Okay, to add or subtract matrices, they have to be the same dimension. They must be the same dimension. Now, I will show you in the calculator here what you could do is you can go to matrix and let's edit matrix A and B. We'll use the same two matrices, 2, 4, I'm sorry, nope, those aren't the elements. The matrix is a 3 by 2 with the elements 2, 4, -3, 7, 5, -6. Matrix, let's edit matrix B. That's a 3 by 2 matrix with the entries 1, 5, 2, 6, 4, -2. Well, now let's quit that out. If I go to second matrix, select matrix A plus matrix B, and I add those together, notice I get 3, 9, -1, 13, 9, -8. If I want to subtract the matrices, matrix A minus matrix B, and I get 1, -1, -5, 1, 1, -4. So I can use the calculator to add and subtract matrices. I'm not sure how necessary it is. I feel like it takes me longer to put the matrices into the calculator than to actually do the work myself. Again, the key here is though that to add and subtract matrices, the matrices must have the same dimensions. We'll talk about scalar multiplication, like to scale something. If you think about your phone, your iPhone, whatever phone you have, as you zoom in, you scale that picture. You zoom in, the proportion remains the same. You just zoom in closer out. You're doubling the size. You're multiplying by a half or something. So in scalar multiplication, I'm simply going to multiply each entry in the matrix by that scalar. So I'm going to do 6 times 2, 6 times 4, 6 times -6, 6 times 3, 6 times -5, 6 times 7, Notice I've scaled up. I've made every element in that matrix 6 times bigger. Number 6, negative 2 times 1 is negative 2. Negative 2 times 0 is 0. Negative 2 times a negative 3 is a positive 6. Negative 2 times the 4 is a negative 8. Negative 2 times negative 5 is 10. Negative 2 times 6 is negative 12. And there we go. Again, I can use the calculator to do that. I'm going to edit my matrix A to do number 6. So my matrix A is a 3 by 2, not a 3 by 3, a 3 by 2 matrix. 1, 0, negative 3, 4, negative 5, 6. So there's my matrix A. If I now just want to multiply that by negative 2, all I need to do is negative 2 times matrix A. Enter, and I have the same thing I got. Negative 2, 0, 6, negative 8, 10, negative 12. Okay, so scalar multiplication, matrix addition and subtraction isn't too difficult, pretty straightforward. In fact, I think it's easier to do it without the calculator than with, but the calculator is there as help or aid as you deem necessary. The last thing I'm going to cover in this video is called transposition, or to transpose. Okay, if A is an m by n matrix, its transpose is the n by n matrix. In other words, you're pretty much inverting, you're transposing. The rows become columns, the columns become rows. Number 7, A is a row matrix, 2, negative 4, 5. Its transpose is 2, negative 4, 5 as a column. Rows become columns, columns become rows. B, now what you'll notice here is, this will be a little bit more easy to observe, I think. B, in number 8, is a 3 by 2 matrix. B transpose is going to be a 2 by 3 matrix. Notice that the first column is 5, 6, negative 5. In B transpose, that 5, 6, negative 5 is the first row. Negative 3, 7, 2 is the second column. In the transpose, that becomes the second row. Again, I can use my calculator for that, and we'll do number 8. Let's make our matrix, let me use matrix B. So let's make matrix B the 3 by 2 matrix, 5, negative 3, 6, 7, negative 5, 2. I'm going to quit, go back into my matrix. I'm going to select matrix B, go back to matrix. When I go to math, look at option number 2. You see that 2 kind of floating like a subscript, that T floating like a superscript. That's transpose. So B transpose is the matrix 5, 6, negative 5, negative 3, 7, 2. So everything with the matrices I can do using the calculator. Again, you can deem how necessary it is for you to do that or not. This video is pretty straightforward, I believe, with matrix addition, subtraction, scalar multiplication, transpose. Please come back for the next video, matrix multiplication. If you're finding these videos helpful, please remember to like or subscribe. That helps